Now that we know how to solve systems of equations, let's use these tools to solve some real-world problems. In this problem, Ava has $10.25 in quarters and dimes. She has a total of 65 coins. How many of each type of coin does she have? The two unknowns in this problem are the number of quarters and the number of dimes, so I'm going to use the variables q and d to represent those two quantities. My first step would be to write two equations that express the relationships in the word problem. There are two basic ideas here. The amount of money Ava has, which is in total is $10.25, and the total number of coins she has, which is 65 coins. The two equations I came up with are 25 cents times the number of quarters plus 10 cents times the number of dimes equals the total amount of money Ava has, $10.25. And of course, the total number of quarters plus the total number of dimes equals 65. Now, I'm going to solve the system of equations and find the value of the two unknowns. I have two methods available to me, substitution and elimination. The first method I'm going to use is substitution. So I'm going to take this first equation and I'm going to solve it for d. This way I'm going to describe one variable in terms of another. I've solved that first equation for d, so d equals 65 minus q. I should mention that I could have solved this equation for q, but I decided to solve it for d. It'll work both ways though. Once I've described d in terms of q, I have an expression, 65 minus q, that describes d. So I can substitute 65 minus q anywhere I see the variable d. So I'm going to take the first equation, and I'm going to substitute 65 minus q in for d. When I solve that equation, I find that q equals 25. Now I'm not done because I need to find the number of quarters and the number of dimes. So I'm going to use the quantity 25, and I'm going to substitute that back into q in both equations. And when I do that and solve for d, I find that d equals 40 for the first equation and d equals 40 for the second equation. So I can come to the conclusion that Ava has 25 quarters and 40 dimes. Instead of using substitution, you might have also used elimination to solve this system. Now, there's no one way to solve using elimination. The method I'm going to use is just one possible way, but we know that the main idea is to eliminate one of the variables. So to accomplish this, the first thing I did was multiply this first equation by -4. When I do that, I turn this 0.25q into a -q. Then the 0.10d turns into a -0.40d, and this 1025 turns into a -41. Then I'm going to take my new equation and I'm going to combine it with q plus d, and when I do that, I eliminate the q's. -q plus q is 0, -0.40d plus d is 0.60d, and -41 plus 65 is 24. Solving for d, I find that d equals 40. Now, I already know from the last example that I'm correct, but just to make sure, I'm going to substitute 40 back into both equations to solve for q. And when I do that, I find that q equals 25 and q equals 25. So I'm confident in saying that Ava has 25 quarters and 40 dimes. Let's take a look at another example. In this example, Beirang has $175 in denominations of $5 and $10 bills. He has a total of 28 bills. How many of each type of bill does he have? So the two unknowns in this problem are the number of $5 and $10 bills. Let's use the variables f and t to represent the number of $5 bills and the number of $10 bills. So for step 1, we're going to write two equations. One equation will express the total amount of money Beirang has, and the second equation will express the total number of bills he has. Now, why don't you pause the video and try to write these equations down yourself. Pause the video now. All right, let's see if you came up with the same thing I came up with. So to express the total amount of money Beirang has, I'm going to multiply $5 by the number of $5 bills he has, plus $10 times the number of $10 bills he has, and we know that that equals $175, the total amount of money Beirang has. Now, to express the total number of bills Beirang has, we add the number of $5 bills to the number of $10 bills. And now we have two equations. To solve this system, we can use substitution or elimination. The first method I'm going to use is substitution. So I'm going to solve this second equation for f. I could have solved for t, but I chose to solve for f. So f equals 28 minus t. Now I can substitute 28 minus t in for f in the first equation. And when I do that and solve for t, I find that t equals 7. But of course, I'm not done because I've only found the value of one of the variables. So I'm going to substitute 7 in for t into both equations. And when I solve for f in both equations, I get 21 and 21. So I'm very confident in saying that Beirang has 7 $10 bills and 21 $5 bills. Another way of solving the system is by using elimination. I'll first start out by multiplying this second equation, f plus t equals 28, by negative 5. When I do this, I get negative 5f minus 5t equals negative 40. I did this because when I combine the two equations, 5f and negative 5f cancel each other out. I've eliminated one of the variables. Then 10t minus 5t is 5t, and 175 minus 140 is 35. Dividing both sides by 5, I get t equals 7. But again, I'm not done because I have to substitute 7 back into both equations to find the value of f, the number of $5 bills. And when I do that, as expected, I get f equals 21 and f equals 21. So I'm confident in saying that Beirang has 7 $10 bills and 21 $5 bills.